Okay, time to move into infrastructure services, the things that support the connectivity of the network. Bring the objectives over here really quickly, and we're on infrastructure services, which is objective 4.0 with 4, 1, 2, 3, and 4, 5, and 5, 6, 7. So it's 15% of the exam. DNS, DHCP, then there was some troubleshoot. We're going to do the configure and troubleshoot separately. What I'll do is go through the slides and talk the theory portion of it, and then we'll go back and do a couple of demos on how to actually configure these things. Two separate entities. Actually, I'm going to split this thing up: DNS, DHCP, and then we'll talk about NTP, Network Time Protocol, and then access control lists and NAT will be separate modules in their own. So the first one here, we're going to talk about DNS and DHCP, Domain Name Service and Dynamic Host Configuration Protocol. Two things that we need to communicate, two things that we use on a very regular basis, unless you're using static addresses on your home network, of course, but we have to have those in order to make them work. So the first one, DNS, is a TCP IP, name resolution service that translates a FQDN, fully qualified domain name. Fully qualified domain name is the host name plus the domain name. Help plus google.com is the help.google.com website. www.esaa.com. ESA.com is the domain, and www is the host. So FQDN, which is the domain name of a specific location in the DNS hierarchy, into an IP address. So this translates it, the name, www.esa. We're going to use this thing one of these days. We're going to translate that to an IP address, because our computers do really well with numbers, not so well with the English language or the German language or the French or anything else. A domain is a group of computers whose communication is managed as one unit. Whoever owns ESA.com owns all of the systems in there. If we had Cisco, would have a whole bunch of things, help, www, help, or whatever else, training. All of those addresses would be managed by one unit, by an individual. They own all of the things that end with Cisco.com. So that's what we're talking about when we say that it's managed as one unit. It's a unique name that identifies a domain name, and you've probably been on the internet. They try to sell you domain names, those that are available. Host name is a unique name given to a network node server at a specific location, printer, on a TCP IP network. A host name combined with the host domain forms the node's FQDN, fully qualified domain name. I probably can never get that one done. Fully qualified. So FQDN, kind of some important letters to remember. Domain names. A domain namespace consists of the information about the hierarchy of the domains and the hosts under each domain, which is referred to by DNS servers for mapping domains. FQDN denotes the specific location of the host in the DNS hierarchy from the top level domain to the last. I want to do one more slide and then take a look at a DNS server. The DNS lookup process. How does this work? We go in and type in this case, www.cisco.com. The DNS resolver, the resolver is our workstation. So we send it to our DNS server, whatever it may be. Maybe a local server, maybe one of the Google servers on the internet, maybe one from our ISP. If that server has an IP address of www.cisco.com, it immediately sends it back to us so that we can go to that IP address. So we're resolving name to IP. If it doesn't have that name in particular, we get a 1 here. Step 2 is we go to the root, and the root's represented by a dot. So we go to the root server and ask the root server, say, hey, I would like the IP address of www.cisco.com. Root server says, I don't really know what that is, because it'd be an awful lot of addresses to keep on one server. But here's the DNS referral message. I can tell you how to get to the .com DNS server. So we go to the root. The root gives us the address of the .com. So we go to the .com DNS server. And the .com DNS server says, DNS referral message, I don't really know how to get to www.cisco.com, but let me tell you how to get to the Cisco name server. So we go to the Cisco name server. It's probably something like ns something name server.cisco.com. And it then sends us, NS1 actually it is, cisco.com or NS2. It sends us the IP address of www.cisco.com. So now we can get to that specific location on the internet. Some issues that we might have: unable to communicate with the server. We can't talk to it. And the issues there with wrong address for the DNS server. And the DNS server is something it's going to be given to us, or we're going to type in. We're going to talk about DHCP here in just a minute, and DHCP typically gives us the IP address and other configuration information for our IP addresses. So we may have the wrong address, wrong path. Routers got the wrong path. It's not sending us to the right location. We have a wrong record. We're given a wrong record. There's a wrong record in the DNS server. That might happen in your, let's say, in your network in an Active Directory, where you move a machine from one location to the other, and the DNS record hasn't timed out yet. So a wrong record. And it says use the ping command to check the operation. Can we actually ping the IP address of the DNS server? DNS not a real complex operation, but it's something that is necessary. What I want to do, I'm going to drag over here a virtual machine, a Windows virtual machine. This is a Windows DNS server. We can close all of this up. If we go into it, we have things that we would manage down here. There's nothing in it but forward lookup zones, which would be the IP addresses of our network, which would be there. If you use Active Directory, it'll populate it for you. Reverse zone lookups, and a reverse zone lookup translates an IP address to a name. So reverse lookup, lookups, and then we have forwarders or conditional forwarders that say if you can't find something, then send it to a specific location. But what we're interested in right now are the cached lookups, the things that we tried to go to, the locations we tried to go to weren't there, and our server then went out and got those addresses. When it gets those addresses, it caches them, and we start with the root here. Now let's just go to the Cisco one. We go to the .com, and you can see there's a whole bunch of .coms in here that have been identified or resolved. We go to Cisco in here. We have www.cisco.com, and we have the name servers, www.cisco.com.akadns. It's an alias name here for the www, and we also have the name servers here. Let me go to one other one that may be a little bit more straightforward. ESAA.com. Well, it timed out. Let me pause and ping a couple of these and see if I can get the wwws back in, because I had them there a couple minutes ago and they've timed out, because the records do not stay forever. Okay, I just pinged these and we're at ESAA. We have a www, a host record, an A record. We have an IP address, an IPv4 address. We also have an IPv6 address. Okay, here we do have still, when we have the IPv4, IPv6. If you have both IPv4 and IPv6 running, your Windows machine at least will try to use IPv6 first. So different things, different look at a DNS server. It is truly hierarchical. That start with the root and work its way down to the individual station, individual host. The next thing that we want to talk about is DHCP, the Dynamic Host Configuration Protocol. It's used to send configuration information to our clients. By default, most clients, Linux I believe is, and I know Microsoft by default are DHCP enabled, automatic IP addresses, which means that it's going to ask a service to send it the name, or not the name, but to send it an IP address and other configurations that go along with it. Used to send the configuration information to a client. The client typically going to be a workstation, a computer. The information that it sends includes the IP address, the subnet mask, the default gateway so that we can get out of the network, the address of the DNS server so that we can resolve things, and maybe a TFTP server. TFTP server is going to be important in Cisco for configurations and Cisco phones to get their configuration information. And if you actually do an automatic configuration of a Cisco router, you need a TFTP server to send its information. I'm going to have a couple of other slides about DHCP, and we'll talk about TFTP when we talk about the TFTP option. Windows is default enabled. It's a broadcast protocol, port 67 and 68 UDP to do those things. The addresses are grouped as a pool, and then actually in Microsoft they're going to be called a scope, so you may see them called a scope or a pool. Cisco is going to call it a pool. And we lease the address. We lease the address for a certain amount of time. The process that we use is the client comes online and sends a DHCP discover message to discover a DHCP server. When the server gets a discover message, it sends an offer, and this is broadcast. It sends an offer back to the device. The device then will send a request, say, yep, I request that address. If we have more than one server, all of them will answer. It will request the address from the server that responds first. After the request, the server then acknowledges that we have taken its address. We lease the address for a certain amount of time. We, the administrators, control the time. Machines can renew the lease, and will try to renew the lease when it is 50% the time is done. In other words, if we had a 4-day lease, then at 2 days it will try to renew the lease. If you can still contact the server, nothing's happened that is offline or anything, and there's no reason we didn't reserve that address for something, or give it to somebody else, take it out of the scope or the pool, then it should be renewed. If it's not renewed at 87.5% of the time, it goes into the panic mode and tries to find any DHCP server to give it an address. At 100% of the time, it gives up gives it up. Just like if you had leased an apartment, when the lease expired, they'd expect you to move out. When the lease expires, they expect us to give the address up to move out. The DHCP server protocol automates the assignment of IP addresses, subnet masks, gateways, other parameters. Is configured with several settings to enable the IP address assignments, subnet IDs, masks to determine the IP address, IP addresses of the default router on the subnet, IP addresses of the DNS server, reserved or excluded addresses that are not available for release. Reserved addresses is where we go into the DHCP server and explicitly assign an IP address to a MAC address, and this is the configurations can be based upon MAC addresses. The host sends a discover message to communicate with the server, offers at least the thing that the process that we saw in the little image. DHCP is a broadcast protocol, and as you recall, a broadcast protocol will not go past a router. What we like to do is, if we have a router here and we have a DHCP server here on a network and we have a whole bunch of subnets out here, we like to do centralized control, so central control of the DNS server. What we're going to do in that case, and we have a slide here in a second, I want to talk about the concept first, is configure something called a DHCP relay agent, which relays the broadcast that it intercepts to the DHCP server. DHCP server then sends the answer back to the router. Router sends it back on the network. So the process is the same, except we use the relay agent in order to relay the information from one to the other. So the DHCP relay agent here, central management desirable, it's a broadcast protocol. The router stops broadcast. If using a broadcast address a subnet, isolation, we need help. If we're using this to do isolation, then we're going to need help. Need either a whole bunch of DHCP servers, one on each subnet of process to use the routers, or we use a DHCP relay agent. And in Cisco, to configure its IP helper command, IP helper, and then the address of the DHCP server. So in this case, if we had configured our router as the DHCP server, the relay agent would send requests, which the DHCP client is going to send its broadcast up here, send the discover message to the DHCP server. It's going to send its offer back to this router, to the relay agent, which will then send it back to the client along the path. We can have DHCP servers configured on the router, or we can have DHCP servers like a Linux server or a Windows server. What I would like to do now is to bring back my I can find it. Bring back my virtual server and get rid of DNS and open the DHCP server. So when we go in here, and again, this is Microsoft, it's going to be called a scope. So what we can configure is an address pool, a range of addresses that we're going to give out to clients. My thought on this, there's a couple of things to talk about reserved addresses. We could use the .1 to the .254, and then we could reserve addresses for our servers, the things that need static IP addresses. DNS servers, for instance, need a static IP address. Or we can just not put the statics in the range, and then we wouldn't have to worry about it. We have address leases, and we don't show anything here because there's nothing on this network to actually get an address. If we were giving out addresses, the leases would be here, what addresses is here, and when is it going to expire. Reservations, just as a new, quick and dirty, a reservation name, the IP address 192.168 or 146.3, the MAC address, and then the description. So we're going to put together or relate together or configure together a MAC address of a client and an IP address, the one that we want it to have forever and ever. So we have options, scope options here. Configure the options look at, there are a whole lot of options when we look at this thing. Time offset, time server, name servers, cookie servers, DNS servers, Impress servers, boot file, root path. So lots of different things can be configured in DHCP. It sends the IP address, but can and does send a lot of other configuration information along with it. And again, back to the DHCP relay agent, it is used to overcome the fact that when we're in a routed environment, we want to use a centralized server, then it is available to do that, to allow a single piece of hardware to give multiple addresses on multiple networks. Issues: relatively simple broadcast protocol, kind of like works or it doesn't work. The things to look at is the server functioning. Have we exhausted the address pool? Because when we use all of our addresses, we're done. We can't give out anymore until some of the lease times are up, or we go take some of the addresses back. Is the client in the same broadcast domain? And the question there revolves around if we have this server here and it's on a 192.168.1.0 network, it can give addresses on the 192.168.1 network. If we plug put an address pool in here on the 192.168.3 network, until it has a .3 address, it can't give those out. The reason that the relay agent works is it would be coming from a 192.168.3 address. It would go here and it says, oh, this comes from the 3 network. I'll give a 3 address back to that area. And then the other one is the relay agent properly configured. Is it going to the proper address for the DHCP server, and is it coming from the proper address? If we have a router here and a router, the address that the interface that the relay, the IP helper command needs to be on, is the address that you'll get there in a second. The interface with the address that we're going to, the network that we're going to use, so that we have that capability. The TFTP option, TFTP is an application layer protocol. It's a simplified version of FTP. Application layer protocol used to transfer configuration files between Cisco devices. The command that we're going to use is copy start. Let me start up config start, and then TFTP. TFTP is a piece of software running on a workstation that allows us to store configuration files and IOSs. The configuration files are handy to have. The router fails, you put in a new router, put an IP address on the interface, copy your configuration, restart your router, and you're back in business, because you don't have to go back and put in the 800 configuration commands that you had used. So it's a simple version of FTP. It uses user UDP, user datagram protocol UDP, as a transport protocol, providing basic file features in the network. Many Cisco devices, most commonly Cisco phones, receive their configuration files from TFTP servers. TFTP option is used along with the copy command to move configuration files between a switch's RAM or NVRAM, volatile or non-volatile RAM, and a TFTP server with the copy whatever. If we're going to copy the running configuration, we could copy run tab running dash configuration and then space TFTP. It'll go through a series of questions like what's the IP address and those sorts of things. If it fails, the TFTP server will tell you that it fails, not TCP, because it's a UDP protocol. On the NVRAM or TFTP server, when the file is copied, the existing file is erased and replaced by a new file. NVRAM or TFTP server. NVRAM is startup config. So if we copy TFTP start, copy it from the TFTP server to the startup RAM, is replaced. If we copy it to the running config file in RAM, the existing file is appended and not replaced, so we can wind up with extra commands. Just kind of a handy thing to know. If you copy it and you say, oh, this is not right, why isn't it right? Because if you copy it to the running config, then it appends the commands to the existing running config. If we copy it to the startup config, it replaces the startup config. We see DHCP options. Servers configured. The domain name DNS server, we looked at those, must be configured on it. Domain name such the domain name and the DNS server. Command defines a list of DNS server addresses on the network on the DHCP server. Gateways, default gateway are network agents, act as relay agents to facilitate communication between client servers residing in different physical networks. Default gateway is the router that gets you off of your network. Default gateway identifies a DHCP message with a broadcast address as a destination IP address. It performs steps, modifies the source address of the packet to the IP address of its incoming interface, sets the DHCP server's IP address as the destination address of the packet, and then routes the packet to the DHCP server in unicast mode. What we're really looking at here is what happens with a relay agent. Default gateway to work as a relay agent, the IP address of the default gateway must be configured at the DHCP server, and we'll do that when I do the demos. I'll show you what we're going to do with that, how to configure those. So what we've talked about is DNS, domain name service, the DNS process, what DNS does, name to IP resolution, the DHCP process, DORA, discover, offer, request, and acknowledge. We talked about and looked at a DHCP server. We talked about the DHCP relay agent and a little bit about TFTP, trivial file transfer protocol. I'm going to stop here and then we'll pick up with NTP, network time protocol, and after that we'll do some demos. See you there.